So for this example that I was promising you, okay, which is basically a simplified, so EE407, let's say, extra example. Okay, so this is this simplified economic model, which is from Lung's book. Okay, so a simplified economic model. In fact, it's a simplified Keynesian model. This is from Lung's book, from one of your reference books. Okay, this is a simplified Keynesian model. Keynes is a famous economist. This is known as a multiplier accelerator model. Multiplier accelerator model. This model is by its nature discrete. Okay, so this is a discrete time model by nature. Okay, so this is an example on a system being discrete time from the beginning, from its first principles, and not because it was discretized by an approximation of the derivative. Okay, so let's define our variables. Okay, our fundamental variables. So we have our fundamental variables. Let me try to use a different color for that. I don't know which color should I choose. Okay, so we have y of k. K is the discrete time variable here. This is the GNP, or gross national product. Gross national product. What is that? Well, this is nothing but the total monetary production. That means anything of value produced by the country. Production of the country. So what the country produces as a value is called as the gross national product. Okay, here k is the discrete time variable. Discrete time variable. Okay, we have C of k as the total consumption. The total consumption at time k. So we have the consumption of the country. We have I of k. So consumption is anything that you consume. It's like consumer products, you know, it's not transformed into anything else, and it's not saved. Okay, so we also have the total investments at time k. Okay, so we have consumption as well as investments. We also have what is called government expenses. So that is considered to be one of the primary variables. So government expenses at time k. Okay. So government expenses are considered to be a separate entity, and we will see how these variables will affect each other. Okay. So let us take a look at what we have as a fundamental conservation law. Remember our conservation law, we can have inflow minus outflow is equal to accumulation. So we have to see how we can apply this into this economic model. So in economics, we can transform this into income minus expenses is equal to savings. So if you have more income than your expenses, you have savings. Okay. Now, in terms of our variables, we can write this as, what is our income? Our income is what our country produces. So we have y of k as our income minus our expenses. What are the expenses? Well, we have the consumption, ck, and then, we have government expenses. This was my, this supposed to be g of k, the government expenses. So g of k, the government expenses, and that needs to be equal to our savings or investments of our country, I of k. Okay, so income minus expenses equal to savings. So that means gross national product minus summation of the consumption and the government expenses has to be equal to the investments. Okay. So if we rewrite this, we have y of k as our fundamental equation, is that we have c of k plus I of k plus g of k is the main conservation law. Okay, so that is one of the equations that we will incorporate into our model. Now, there are other relationships between these variables, and unfortunately, these are not kind of cast in stone, okay? But there are many suggested models for the interaction of the other variables. This conservation law is fairly established, but other relationships among these variables, among these fundamental variables, are open to debate, and obviously in the field of economics. Okay, one such model is by P. Samuelson. He suggested the multiplier accelerator model. Multiplier accelerator model, and we will see what that means in a minute. It is a simplified Keynesian model. Okay, so let's discuss what that implies for our variables. Okay, now it suggests that there are interesting dynamics between these variables. The first one is that the consumption in the current year is proportional to the gross national product of the previous year. So what this suggests is that we spend, as a society, we spend in linear proportion to how much the country has gained in the previous year. Okay, so if we have made more money last year, we spend more this year. Okay, so consumption in the current year, consumption in the current year is proportional to the GNP, the gross national product of the previous year. I mean, if you felt like the country is poorer because things were not great last year, as a society we have a tendency to spend less. So our consumption this year, or consumption right now, is linearly proportional to what happened the last year in terms of the gross national product, with a proportionality constant that is positive. Okay, so that is another equation. Note that this is a difference equation, so it corresponds to like a differential equation in the continuous time, right? You have ck minus so ck ck is equal to a times yk minus 1. Okay, now also investments are proportional to the increase in consumption from the previous year. What's the logic behind that? Okay, let me write it down and then we will discuss it. Investments in the current year are proportional to the increase in consumption from the previous year. First, let me write the equation down. Investments at the current year is equal to B times, this is the proportionality constant, CK minus CK minus 1, a difference equation. B being a positive constant. What's the logic behind that? Well, it argues that companies invest by observing how much consumption has increased from the previous year. If people are spending more from last year to current year, that means that you are confident that people are increasing their spending. Therefore, companies invest in order to grow. Okay, if you're a sales company, let's say if you're making, let's say, t-shirts, and you see that people are spending more on t-shirts from previous to current year, you invest into manufacturing more t-shirts. Okay, so that's the logic of how investments are moving. Sorry, let me make it like this. Okay. Now these are it's as a note. These are reasonable proposals, and are consistent with observed data. So you can think of these as part of the experimentally measured behavior of the system. Okay. So think about what type of a model is this? Okay, what type of a model is this? I mean, things, is it like continuous or discrete time, right? We have discussed that this is a discrete time model because we don't have a continuous time variable, but we have an index k, which just, in this case, it's a yearly, k equals 1 and k equals 2 means a year has passed from between the k values. Okay, is it deterministic or stochastic? Now, although you might argue that many things in economy might be stochastic in nature, this model itself does not have anything that is random. Okay, it's just a deterministic model defined by equations, difference equations from the previous year to the current year. Is it static or dynamic? Well, we can say that this is a dynamic model because we have difference equations. In the discrete time, difference equations correspond to the differential equations in continuous time. And remember that you have a static system when you actually have only algebraic relationships. Whenever you have differential or difference relationships, you have a dynamic system. Okay? Is it linear or nonlinear? Well, think about that. Okay? Is there any nonlinearity involved? Maybe we will be more confident when we derive the entire set of equations, the final set of equations. Okay? Now, what is the... Now, so what is the aim? Okay? The aim is here the economist's aim, okay, or the government's aim, okay? So the question is how the government can control, or we might call it influence the economy by different interventions. By interventions, we mean whatever the government has, like taxes, extra taxes, some other incentives for you to save money, and so on. Okay. Now, what is the goal variable? What are we really interested in? We are interested in improving the gross national product. So the government is interested in boosting the economy, meaning that government wants to increase the gross national product. Okay, so assume that goal variable, we can call this the output actually, the output variable, is the gross national product, y of k. Okay, so we want to boost that variable. Okay, so what can the government do? What are the control actions? Okay, Let me give you some examples of what government can do. So, for example, government can influence C of K, the consumption, via taxes. Okay? For example, increase sales tax to reduce consumption. Right? This is logical. I mean, if you have more taxes, you are less inclined to spend your money because you are pissed off that a lot of money is going to the government instead of on what you are buying. Okay. Another example, you can influence, or the government can influence the investments I of K via bank interest rates. Right? If bank interest rates are higher, you are more inclined to invest your money in the bank, to save your money in the bank, because you feel like it's earning you more money as an individual. Okay, so you can influence the investments by playing around with the interest rates. Okay. Also, if you lower rates, also make it easier to borrow. Hence, increasing investments. This time for the companies' investments. Okay, so lower rates this time encourage companies' investments into. Sorry, I confused I of T with savings in my previous comment. Okay, so higher interest rates from the banks increase savings, but lower interest rates from the banks makes it easier to borrow, hence increase the investments from the companies. Okay. But now we will investigate something else. We will investigate government expenses. Okay. We will investigate government expenses, G of K, in how it is as the main actuator. That means the main tool to influence the economy. Okay, so let's see how government expenses play a role. Okay, so what we will try to do is we want to find a relation between G of K, the government expenses, and Y of K, which is the gross national product, by eliminating C of K and I of K from the equation. Okay.